Okay, so let's say we have a sphere of radius, let's say r naught, and the sphere is uniformly charged. So let's make a few plus signs. And the total charge is, let's make it red, it's capital Q, or capital Q naught. That's the total amount of charge. And let's say that we want to integrate along a closed path of radius, let's say 4 r naught. Okay, so we're gonna integrate along a circumference that takes me off our sheet, but here's part of that path. So I'm going to integrate all the way around. I want to integrate the electric field all the way around. So let's make a few. So what I want to do is this calculation. I want to integrate the electric field, and this is a closed path, around this path. So let's say I start here. These are my DRs. Right, here's a DR right here. They're tangent to my circle, and so on, all the way back around. First, I need my electric field. So to get the electric field everywhere along this path, at least in magnitude, I can use Gauss's law, which says that the integral of the electric field over a closed surface, right, that's different from a path, right, that's the integral over a surface, and that's a closed surface, right. dA is not dr, two different kinds of physical quantities. This is an area and this is a length. Gauss's law says that this is equal to Q enclosed over epsilon naught. So we're combining ideas here. We're going to get the electric field from Gauss's law, and then we'll integrate the electric field. So I have to pick a surface, and I want a surface that goes through the points that I care about to do my electric field integral. So this is a sphere. I'm going to calculate this side using a sphere of radius 4 r naught. So I get the electric field is everywhere the same there. So I get electric field times the area of that sphere, and the area of a sphere is 4 pi times the radius squared, but the radius is 4 r naught, so I'm going to square that. That's the left-hand side. The right-hand side requires that I look inside to see how much charge is enclosed in the sphere that I use for the left-hand side, and that sphere has a radius 4 r naught, and so all of the red charge is inside of that sphere, and so this becomes Q naught. I divide by epsilon naught, so I get, right, this side becomes, this gets squared, so it's 16 times 4, that's 64, right, 16 times 4 is 64, I have pi r naught squared, and that's equal to Q naught over epsilon naught. So the magnitude of the electric field, sorry, I already put an arrow on there, so I'm going to turn this into a vector, is the full vector is Q naught over 64 pi epsilon naught r naught squared, r hat, because it's radial. So that's the electric field, and now I'm going to integrate that along the closed path. So this calculation requires that I do E dot dr. So this looks like Q naught over 64 pi epsilon naught r naught squared, r hat dot dr. But when I look at the dr, so let's write the red electric field at every point. I know the magnitude, but I also know the direction, right? It's radial. And my drs are not radial. They're perpendicular to that direction. So the electric field is there everywhere perpendicular. And so this gives me an integral of 0 at every point. So there's nothing to integrate. And I get 0.